Now continue from previous videos where we have designed the slab for the strength, deflection, and we done the reinforcement detailing in the last video. Now we need to determining the last part of this one, where you need to find the determining the total floor loads on the beam ABs and beam AC. So this slab are putting the the dead load due to the weight of the slab is on the AB, and the weight on the beam AC. So we need to calculate the beam AB and beam AC. So for two-way slab, the distribution of beam AB is a short span, so it will have a triangle, and beam AC is a long span of the slab, so where you will have a trapezoid area of load distribution. So that slab has a distribution of loading in that fashion. For along the long span, along the short span you have distributions going on that span. Now where you can find this displacement, where you can find this information, that is given in AS3600. If you come back to the clause 6.10.3.4, it has load allocations, and for that load allocations it will show that this is a short span. So along the short span you have this triangles distribution, along the long span you have this distribution, and that is the 45 degrees. So we are going to use that concept. Now for beam AB, that's what I write in the clause. The total load equal to tributary area times the load that we calculated. Now to calculate a tributary area, we have these triangles for beam AB. This is discontinuous beam, so we have only one triangle here. Please note, if you have this one here, you need to have two triangles, and then you can calculate the area of those two triangles. But here we have only discontinuous, we have only one triangles. So 5.5, which is 5.5 here, 45 degree here, that is coming from the standard figures, that 45 degree here. If you have this 5.5 divided by 2, you will so this 2.75 here, you can have 5.5 divided by 2, you can get 2.75 here. Now for similar triangles, if you want to calculate this height, so 2.75 times by 1045, it gives me 2.75 height. So 2.75 here, 2.75 here. Now once you know these triangles dimension 5.5 and 2.75, you can calculate the area of these triangles, right angle triangles, which has base and height. So 1/2 the area of the triangle, this triangle here, half times base times height. So half base is 2.75 times by height 2.75, you get 3.8 meters square. So tributary area equal to area of the two triangles, because you have this area, tributary area is this one for A and beam AB. So 3.8 plus 3.8 give me 7.6 meters square. So the total load is equal to tributary area times by the Q star. Now we calculate that Q star. We calculated that Q star based on that 1.5 meter 0.15 meter depth of the slab. So we have 9.6 kilopascals, that is kilonewton per meter square. So that I substitute here, 7.6 times 9.6 give me 73 kilonewtons. This meter square cancel, so that is 73 kilonewtons. So this AB will have a 73 kilonewtons load due to the dead load and live load on the slab. Please note the self weight of the beam AB has not considered here in that load calculations. Beam AC, so beam AC is along this long span. Again the same equations, total load is equal to tributary area times Q star. Now that area, tributary area, is a trapezoidal area. So the area of trapezoidal is A plus B over 2 times H, where A is a small length and this is the larger length B, and the height is between this height. So this, how do I calculate this one? 7.5 meters given in the figures. Now these triangles, if you remember that these triangles, that height was say 2.75, so that height is 2.75 here, that height is 2.75. So 7.5 take away 2.75, take away 2.75 is 2 meters here. This height is 2.75, because if you work it out, this height from here to here, which is half of 5.5, which is 2.75, so that height is 2.75. So A is 2 meters, B is 7.5 meters, height H is 2.75 meters. So the area is equal to 2, substitute 2 plus B 7.5 over 2 times 2.75, you get 13 meters square. Tributary area equal to area of the two trapezoidal, because this beam will have a load coming from this portion of the slab, which is this one trapezoidal, and on other side you have this trapezoidal. So please note, this is a continuous beam. In that case you will have two trapezoidal. If you are working on this beam, you would consider only one trapezoidal area. So you have two area of trapezoidals, 13 plus 13, so that give you 26 meters square. Total load is equal to trapezoidal area times Q star, 26 meters square, times 9.6. 9.6 is our factored load that we calculated based on 1.2 dead load plus 1.5 live load. Substitute here, meter square cancels, that give you 250 kilonewtons, that loads coming on that beam AC. That is the final video for the calculation of this dead load and the calculation of the total load coming on the beam AB, which is the discontinuous beam, and beam AC, which is the continuous beam. Thank you.